Welcome to EGME-331 Solid Mechanics. In this video, we'll be reviewing on Mohr circle. So what's Mohr circle? The concept of Mohr circle was first developed by a German civil engineer named Otto Christian Mohr in 1895. And Mohr circle is a useful graphical interpretation of the stress transformation. We have seen stress transformation before, and Mohr circle is a method to interpret the stress transformation. In other words, it's a graphical method of explaining the plane stress transformation, and it's much easier to remember, and it provides a functional depiction of the relationships between the stress components, the various stress components, the principal stress acting on a different planes at a point. Mohr circle for a plane stress is constructed with the normal stress sigma plotted along the horizontal axis and the shear stress tau plotted along the vertical axis, as you see in this figure. The circle is constructed such that each point on the circle, on the periphery of the circle, represents a combination of the normal stress sigma and the shear stress tau that acts on a specific plane through a point in the stressed body. Now, if you take a look at the plane stress transformation equations, we have the normal stress here and the shear stress. We could take these two equations, the sigma sub n and the tau sub nt equations, and square them up, add them, and you could get this last equation that you see here. And this equation, if I go to a circular equation format, the equation of a circle, we can see that it matches identically with an equation, something that you have seen highlighted in yellow. The x minus h whole square plus y minus k whole square is equal to r squared, which is a standard equation of a circle. In this case, h comma k would be the center of the circle and r would be the radius of the circle. In our case, we will have sigma x plus sigma y over 2, comma 0 would be the center of the circle, and the radius would be the right hand side quantity of the first equation is a square root. So it will be the square root of sigma x minus sigma y over 2 whole square plus tau sub xy squared. And these two terms, the center and the radius c and r, are used to construct the Mohr circle. Now let's take a deeper understanding of what this Mohr circle actually means. The Mohr circle, as I mentioned before, provides an extremely useful aid in visualizing the stresses on various planes through a point in a stressed body. That means it can be used to interpret the stresses acting on any plane passing through that point. And it's a quite convenient way for determining the principal stresses and the maximum shear stresses acting on the body. If the Mohr circle is plotted to scale, and measurements can be directly taken from the plot to obtain the stress values. And most importantly, Mohr circle is one of the most useful pictorial aid for any stress analyst who is performing analytical determinations of the stresses and their directions at a point. Let's work on a practice problem. So consider a point in a structure member that's subject to plane stress as shown in the figure on the right. So we could see the two normal stress components and the shear stress component. So we are asked to draw a Mohr circle for this particular state of stress and then determine the principal stress and the maximum in plane shear stress acting at the point using the Mohr circle method. So as we can see here, the center would be the sum of the two perpendicular normal stress components over 2 will be negative 7.5 ksi, and the radius would be, using the equation for Mohr circle, we could get 24.05. So using the center negative 7.5 comma 0, and radius of 24.05 KSI. We would construct the circle about the two axes, the sigma axis and the toe axis, and from there we could easily determine the principal stresses. The principal stress sigma sub P1 and sigma sub P2. Sigma sub P1 would be the center plus the radius, and the sigma sub P2 would be the center minus the radius. And the maximum shear stress would be equal to the radius, 24.05 KSI, and the average stress would be the center, be negative 7.5 KSI.